So here's the first example in this topic of parametric equation and curve. And in example 1, there are two parts. A, let's do it in one sentence. Identify the curve defined by x equals t squared minus 2t and y equals t plus 1. Okay? And we can continue and say, then sketch the curve. Okay, I'll take your suggestion how to proceed here. Some of you may have gained experience doing this in trig, or even, actually I said trig, but it's also included in our trig calculus, MAC 1140. So it's both MAC 1114 and MAC 1140. I'm sorry? I can't hear many.
Sketch it.
Well, in order to sketch, we want to have something in x and y. So that's why I said first let's identify the curve and then sketch it. All right, since this is the first example, I'll go ahead and show you the technique here. Since y equals t plus 1, this will be a good starting point. Basically, what we want to do, we want to express either y in terms of x and x in terms of y. This is not necessarily a function, as I stated before. The curve can be just a relation. So we need a relation between x and y. Okay? So in general, in this case, we are looking to find a relation in x and y. Okay, so we let y equals t plus 1, and from here we're going to have an expression for t. Well, t equals y minus 1, right? And now we're going to plug t in x. So substitute t equals y minus 1 in x equals f of t. Okay, so what is x? X equals t squared minus 2t. And now we have something for t, right? And t is y minus 1. So we have y minus 1 squared minus 2 times y minus 1. And all we need to do is keep working on this, clear the parentheses here. So we have y squared minus 2y plus 1. And here we have minus 2y plus 2. Bring it home and you get y squared minus 2y minus 2y, so minus 4y. And there we have plus 1 plus 2 plus 3. So x equals y squared minus 4y plus 3. Okay, this is the curve. Now, can you tell just by looking at it before we start sketching it, what the heck is that? It's going to be what? Somebody started? I'm sorry? We can complete the square, but that's not a bad idea actually. If completing the square will help you, then complete the square. We really don't need to do so, but it's beneficial to complete the square. I agree with you. So x equals, instead of y squared minus 4y plus 3, we'll write plus 4 minus 1. Now this is a perfect square. trinomial, right? It's y minus 2 squared plus 1. What can you tell me about this expression? X equal y minus 2 squared plus 1. What does it smell like? It's a parabola. Very good. What kind of a parabola? Horizontal parabola. This is the parabola where x equal f of y, not y equal f of x. Remember, y is not equal to f of x. Turned out that this curve indeed failed the vertical line test. What do we know about the vertex? Y equals what? I'm pointing at it. Y equals 2 and x equals 1. So this parabola has a vertex x equals 1, y equals 2. Okay? This is what we call the vertex form of a parabola. This is a vertex form of a parabola. And we'll go into more detail when we deal with conic sections, but at this point we're going to say that the vertex will be y equals 2 and x equals 1. So if we sketch that, okay. By the way, what is the axis of symmetry? Well, it will be the y value of the axis. The axis of symmetry will be y equals 2. You can see it from here. The axis of symmetry, if you remember, negative b divided by 2a. So it will be negative 4 divided by 2 times 1. So it's y equals 2. So the vertex will be y equals 2, x equals 1. And the axis of symmetry is y equals 2. Okay, so this is the parabola x equals y minus 2 squared plus 1, or y squared minus 4x plus 3. Okay, where this point is x equals 1, y equals 2, and you can see the axis of symmetry is y equals 2. Right? Okay, that's what happened in year 6. So actually, you're right. This is supposed to equal minus 1 right here. So change it to minus, and x equals negative 1. So what we need to do, we need to move the graph right here to x equals negative 1. Okay, so just change it like so. So the vertex will be negative 1 and 2. Thanks for pointing this out. We need to erase what I did here as being incorrect. This is correct, but this one is minus 1.
So then the bottom one be minus 4y instead of minus 4x.
I couldn't hear, I'm sorry.
Should the bottom equation be minus 4y instead of minus 4x?
This one?
No, on the top, sorry.
This one?
Yeah.
Y squared minus 4y. Yeah. Guys, to be honest with you, it's not like this is the first time I make a mistake, but I'm really, really sick. I'm heavily medicated with both narcotics and antibiotics. So bear with me. I knew that I'm going to make some mistakes today, but that's the way it is. So let's write it here. X equals y minus 2 squared minus 1, or y squared minus 4y plus 3. Okay? This is the curve. I think we got it now. After number of corrections. Who came up with this correction? That was very nice to observe. Was it?
I was thinking it too. I didn't say it.
But who said it aloud? Who is he?
I didn't.
You did. Good. All right, let's do one more example, call it a day, before I make more mistakes here.